Lesson 5, Negative Exponents. Zero and negative exponents. Any non-zero number to the zero power is 1. Any non-zero number to a negative power is the multiplicative inverse of the power. That's a hard word to say, multiplicative inverse. In other words, it's like the flip. And you'll see what that is, hopefully, in the following examples. Speaking of examples, we're going to do some examples using negative exponents and zero. And the directions are write each expression using a positive exponent. So our first example right here, let's go ahead and bring that up a little bit. Right there, we're going to start off with 6 to the negative third power. So we have a 6 raised to the negative exponent, and it says it is equal to the multiplicative inverse of the power. So what does that look like? I mentioned earlier, multiplicative inverse is the flip or the reciprocal of this. So what that is, it looks like this right here. We just move our 6 down into the denominator, and it makes the exponent positive. So this is it right here. That's all it is right there. The multiplicative inverse. Let's go. And let's look at another one. Let's say we have a to the negative fifth power. Again, we want to write this expression using a positive exponent. Well, by the rule, if we have something raised to the negative exponent, it is the multiplicative inverse. So the multiplicative inverse of this is the reciprocal, so 1 over a to the positive fifth power. And there it is right there. So it was a negative exponent. We took the reciprocal and made it a positive exponent. Okay, next, let's take a look what happens when we have a power of 0. So we have this one right here, letter C, 5 to the power of 0. What did it say earlier? Any non-zero number to the 0 power is what? 1. So that's exactly what this is. It's just equal to 1. So any non-zero number, as long as this base is not a 0, and we raise it to a 0 power, it's always going to equal 1. Okay, in these examples, we're going to write each expression using a negative exponent other than -1. So let's take a look at the problem right here. This first one, we have 1 over 5 to the second power. So how can we rewrite this as an expression with a negative exponent? Well, right here we have 5 in the denominator with a positive exponent. So earlier we said we take the multiplicative inverse or the reciprocal to make it positive. Well, since it's already positive, we're going to take the reciprocal of this again. And so that means we're going to put 5 on the top, and we have a -2. Like when I mean on the top, we have the 1 down here, but we don't need this 1, right? This is the same thing as 5 to the -2 power. So I just wanted to show it was the reciprocal. Okay, this one is a little more tricky because we do not have a power down here in the denominator, but we still want to write it using a negative exponent. So first we need to rewrite this 36 as a power. So that means we need a base and an exponent. So what number or factor can we multiply repeatedly to get 36? Right, because there's different factors of 36, but there's a factor of 36 that is multiplied repeatedly. And yes, it is 6 times 6, which is 1 over 6 to the second power. So the factor 6 squared is 36. That's a positive exponent. We want to use the multiplicative inverse. So that means we're going to have 6 to the -2 up here, the 1 on the bottom. And again, we don't need that 1, so it's just 6 to the -2nd power. and there it is written with a negative exponent. Okay, in this next section, we are going to simplify each expression. Once again, we're going to use these properties we've had already, the multiplying and dividing, or the properties of exponents. Here we have a 5 to the third power being multiplied times 5 to the negative fifth power. And there's a couple ways we can approach it. But first of all, I'm just going to approach it the way we've done in the past. We have two powers with the same base being multiplied. So what do we do to simplify that? What have we done in the past to simplify that? We keep the base and we add the two exponents. So that's going to be a 3 plus a negative 5. So we will still add them together, but now we need to know how to add with negative numbers. So 3 plus a negative 5 is actually the same as like subtracting. So because we're subtracting, so we get 5 to the negative 2 power. Now this can be our answer, but usually we want to write it with a positive exponent. So we don't want to stop when we have a negative. So again, we have a negative exponent, so we're going to use the multiplicative inverse. That means we're going to flip this guy like this. So I'm going to have the 1 on top and 5 to the power of 2 on the bottom to make it a positive exponent. And we can stop here, or we can actually multiply that out. So that's 1 over 25, because 5 to the second power is 5 times 5, which is 25. So let's try this next example right here. We have w to the negative first power over w to the negative fourth power. So here we have powers being divided, powers with the same base being divided. We've dealt with this before in previous lessons. So what we've done is we take the base, since they're the same, and with the exponents, we subtract the exponents. So we have the negative 1 minus a negative 4. So we would subtract the two exponents, the top minus the bottom, always in that order. And again, we have to know, do we know how to subtract with negative numbers? Hopefully you do. Subtraction is the same thing as adding the opposite. So that's where we get the keep, switch, or whatever words your teacher told you to help you remember, or keep, flip, change, or something like that. But in this case, so we're adding the opposite. So this subtraction actually can become adding. The opposite of negative 4 is positive 4. So this is negative 1 plus a positive 4. And that will end up being 3. So we have w to the third power. It's a positive exponent, so we can leave it just like that. So this expression will simplify to be w to the third power.